Well, we're going to stay on systems of equations. One thing we have learned already is how to label what type of solutions are going to be. Independent, dependent, consistent, or inconsistent. Well, now we're going to learn how to solve, which means we're going to learn how to take these two equations of those two lines, know that they intersect, and find that point of intersection. So when they say solve a system of equations, that means we are looking for the point, which is an ordered pair, x comma y, that makes both equations true. So the first way that we have graphing. Well, some of us on the first section of chapter 6 did some graphing, and you might have figured out that if you don't graph accurately, or they don't end up being those whole integers, it's a little scary to try to estimate where that point is. So instead of spending a lot of time on that, we're going to go to the next way, which is an algebraic way, and we're going to do solving by substitution. Well, we all know what it means to be substituted. If you play basketball and you're one of the starting five, after a little while you'll be winded and the coach will put a player in for you, and that is a substitution. Always go back to sports. So we're going to take a system of equations and we're going to solve for that ordered pair using substitution. The first thing we must do, okay, is talk about the limitations. All right? You always want to do substitution when the variable has a coefficient of 1. If it doesn't have a coefficient of 1 or negative 1, it gets a little ugly in there. So what I'm telling you is, yes, if the system of equations, because there'll be an x and a y in the first equation, and an x and a y in the second equation, do not have a coefficient of 1, that's a limitation. But we're going to start off easy, and we're always going to use that coefficient of 1. Okay, on the board I have a system of equations. You'll notice the coefficient is 2, coefficient is negative 1, coefficient is 8, and the coefficient is negative 4. If I don't allow a limitation to stop me, then I am going to solve this equation right here for y, because that's the only one that has a coefficient of 1. So let's go ahead, and I have 2x minus y is equal to negative 3. I'm going to take my 2x over to the other side, because I need my y to be by itself. That gives me negative y is equal to negative 2x minus 3. I haven't solved for y, I solved for negative y, so I'm going to divide through by negative 1 on all terms, and y is equal to 2x plus 3. So now this is where the term substitution comes in. I'm going to take my other equation, and it is 8x minus 4y is equal to 12. And since I solved this for y, I'm going to take out my y, and I'm going to put parentheses there, is equal to 12, and that should be negative, Mrs. Manisi. And in the place of y, I'm going to substitute the value of 2x plus 3. So I'm going to take this value and I'm going to put it in here, 2x plus 3. Now I'm going to solve this equation. So I have 8x I'm going to distribute my negative 4, negative, that gives me negative 8x, negative 12 is equal to negative 12. I'm going to solve this. That gives me 0. That gives me negative 12 is equal to negative 12. Well, terrible problem, Mrs. Manisi, but it opens up discussion. If I ever get where my left side is equal to my right side without a variable, that means that those equations are the same line. So therefore, I would have infinite solutions. And I don't have to do anything more. Because I can't list every ordered pair that would make that true. Well, let me pick a better problem to walk through the steps. All right, let's look at my system of equations. And the first thing I want to make sure is I want to solve one of them for one of the variables. But if you look at this, I already have one solved for the variable. So instead of recreating, I'm going to take my second equation and I'm going to rewrite it. And since I have y is equal to, that means I'm going to take out y. I'm going to replace it with my parentheses. And what is y equal to? Y is equal to negative 4x plus 12. I'm going to solve this equation, and that gives me 2x minus 4x plus 12 is equal to 2. I'm going to combine like terms, gives me negative 2x plus 12 is equal to 2. And I'm going to solve this for x. Excuse me, minus 12 minus 12, negative 2x, bye-bye baby, bye-bye, and that gives me negative 10. I'm going to divide through by negative 2. That gives me x is equal to 5. That's my x value, so that would be 5 comma, but how am I going to find this value? Well, I'm going to take my new value and I'm going to plug it into one of my equations. It doesn't matter which one, but I usually go to the top because I like to pretend I'm always a winner. So when I do that, that gives me y is equal to negative 4x plus 12. I'm going to take out my x because it's 5, so y is equal to negative 4 plus 12. I'm going to replace my x with 5, and I'm going to solve. Y is equal to negative 20 plus 12, which gives me y is equal to 8. What am I going to do with that? I'm going to put it up here. How can I make sure I have it okay? Well, I could put it into both of these and see if it makes a true statement. If it does, then I know I have the ordered pair. This right here is my point that would make both of those equations true. Third and final problem. I have a system of equations. My coefficients are 1, negative 2, 3, and 5. So right away that tells me which variable I have to solve for. I have to do this equation and I'm going to solve it for x. So I'm going to bring that down here and I have x minus 2y is equal to negative 3. I want x to be by itself, so I'm going to add 2y to both sides. And that will give me x is equal to 2y minus 3. I'm going to bring down my second equation. Excuse me. When I bring down my second equation, I have 3x plus 5y is equal to 24. I solved this for x, which means I'm going to eliminate my x. I'm going to put parentheses in its place. Plus 5y is equal to 24. And in the place of my x, I'm going to put 2y minus 3. Now I'm going to solve that equation. gives me 6y minus 9, and then plus 5y is equal to 24. Combine my like terms, and that gives me y minus 9, 6y and 5y, that gives me 11y, I'm glad, is equal to 24. Add 9 to both sides. That gives me, I'm going to crawl up here, 11y is equal to 33. Divide through by 11, and y is equal to 3. So my ordered pair is something comma 3. So what do I do with this? Well, I put it into the one that I used, and I solve for the other variable. So when I do that, that gives me x minus 2y is equal to negative 3. So x minus 2, leave out my y, is equal to negative 3. I'm going to put in the value I found, which happens to be 3, and I'm going to solve that equation. So x minus 6 is equal to negative 3. Add 6 to both sides, gives me x is equal to 3. So I put that into the x part of my solution, and that point 3 comma 3 would satisfy both of those equations. Please make sure you do check for understanding.